Okay, so you end every sentence with that's literally go create what you want to create. That's actually so embarrassing. That's one of them. I know you're better. I know you're actually going to code something like this or something like that. In game. Or I'm playing the film. What game is that? I don't play this. I'm just playing this. Whatever. Oh, I got every single observation state question wrong. Like, I was like, should I learn this? And then it was like the day before, because I still studied all of it 2 weeks before this. I got it. So, yeah, I thought it was like really low tiring. I kept getting it wrong. Like, bro, like, chemical. Right. Which one? Oh, why you don't take it like okay. I didn't know we were doing it. The oxygen. All right, I didn't leave the Lions go. I heard. Oh, I minus anorexic ox and my fat cat or something. Yeah. Ox and ox, right? Anorexic. Yeah. Anorexic anode is oxidation. Yeah, the cathode grows, so it's a fact. Red cat. Anorexic ox. Oh my god. I mean, everybody to read school. Well, I mean, what if you were? They make you do a 3-month approximation to save your family. Yeah. Then what? Difference between Taylor and the product. We tell it for all of them. Yeah, the same thing. You integrate the theories. As a very so what's this function? Some maxes and with the big X and the big Y. No, small one. And cat. That's actually much. Like a science, but and then the line and the middle would be with their both. So good. Yep. Great. No, I think I'm going to no, I'm turning the you mean give a group? But you mentioned easy. Well, yeah, we can see the other sentences are this would be a minimal button. Here with all the people you have. But that's not a conversation already. No, they need to be negative. You turn positive beams to kind of first quadrant. You apply this in logic down. Like if everything is the bottom, then everything else.
Oh, like okay, like
you do that right now. No, I can't figure out after the well, chemistry is more challenging.
you don't like that for sure.
Oh, so it's done. Let's so close. Oh my goodness. Oh my god, it's so tough. I just don't. That's like I got like I already heard it. Oh, you made something. You made yeah. No. Four things. Yeah.
Yeah.
No, really hard. Just you wait. What's the if I see? No, I understand. I could have. Find out. But I can put sections on me. Yeah, but like those classes go on. Priority won't help me with like. Smart. Not making enough sense to you. Wait, a lot of
Yeah, I'm so using.
Hate somebody in their regular life is many.
Like, there's like eBay for a second,
Like insurance.
on eBay, modify the perspective, kids, modify it, ARI.
You do the bigger thing.
That's like vector.
Chris, that's not a.
Modify.
Do I use that guy? I can get that for you if you want.
But no. Modify.
Have you ever shot somebody?
Okay, so any questions before we get started? A quick reminder that if you want to submit your partial credit, the deadline is tonight. Okay, so make sure to submit your partial credit, if any, for your midterm two. Okay. And what we are going to go through today is actually about entering chapter 17. So for your midterm three, chapter 17 is actually the most important chapter. Okay, we'll get to hang out for chapter 17. We're going to finish the first part this week and then finish the next part next week. Okay, and after that we're going to cover chapter 18. And that's all we cover for the third midterm. Okay, so typically the students' performance typically is actually the best for midterm three because there's actually not much calculation involved. It's actually more about memorization. So if you did not do really well for the first two midterm is actually a good time to get you some points back. Okay, to improve your overall average for this course. Okay, so similarly, we're going to do the review for your midterm three. Okay, and if we can finish in time, then the very last week before your final exam, you can do another review for the overall 10, 13, 12. Depending on how much time we have left. Okay, but even we don't have much time left, the things you need to do is actually really go back to all these in-person review videos. Okay, so make sure you actually know how to do every single question I say, and then go back and review all the questions that you have you collected from your midterm 1, 2, and 3. Okay, and then maybe check out some of the things that your friend has. That should actually give you a pretty good baseline to really prepare for your final. Okay, so don't give up. Okay, you already passed halfway already. Okay, which is the most difficult ones. Okay, I'll analyze more about our midterm two performance on Thursday. Okay, so we'll know like where we stand. Okay, and but overall, I think it's actually we do reasonably well compared to other sections. So please keep continuing. Okay, and then use your resource wisely. Okay, if you have some resource to use, then make sure you use them correctly. Okay. Yeah, but that's pretty much the things we want to actually cover before I actually go into the real material today. Okay, any questions? Okay, so for chapter 17, the things we care about is actually redox reaction, right? I actually heard many of you say, okay, oxidative state is actually all the worst things that you encounter in the past, right? So it is not that difficult. A few simple rules. If you actually know the rules, things become a lot easier. Okay, so I want to actually focus on the key elements. Forget about many other things. Okay. So first thing first. The first thing I want you to actually learn is to assign the oxidation number of an atom inside a molecule. Okay. So I guess everybody has some idea about what oxidation number is, right? For example, what's the oxidation number of this? That's one, right? Plus one. Okay. So starting from this chapter, two things matters a lot. One is the sign, plus and minus. Okay. Make sure you know they are different. Okay. The other one is actually numbers. Okay. So sign and numbers are both important. Okay. So the oxidation number of H plus, okay, will be 1. Okay. How about this? 0. Okay. How about the H in H2O? When things actually become more and more complicated, you feel like, okay, sometimes I just don't know how to actually say the correct number, right? So that's actually the first thing that we need to learn. So what are the rules? Okay, these are the rules. Okay, so the first rule is what? If you have atom, meaning single atom species, its oxidation number will always equal to 0. Okay, so the example we just went through. Okay, single atom molecule, right? H2 is actually a 2 hydrogen atom forming a covalent bond in between. The same thing for your O2, N2, Cl2. Okay, so if you see these things, this single element, okay, the oxidation number will equals to 0. Okay, so that's rule number 1. Okay. And the other thing I want to pay attention to that is that whenever is N2, H2, O2, what's the overall charge of the species? What's the overall charge of N2? 0. Okay, you need to be very, very confident so you can build up your seed. Okay, so this is the things that we need to be practiced a lot with this week. So that every time we see a molecule, we know, okay, what's the overall charge? Okay, what's the oxidation number of every single atom within that molecule? Okay. Okay, so let's actually rule number 1, right? Rule number 2. If you have a monoatomic ion, then its oxidation number will be its overall charge. Okay, for example, Na plus, the oxidation number of your Na will be positive 1. Okay? How about this? Positive 2. Negative 1. -2. Okay, so if a single atom carry a overall charge, then you know its oxidation number will equal to its overall charge. Okay, that's rule number 2. Rule number 3. Okay, these are the typical things that you have to remember. If you see a molecule, meaning you have multiple atoms within the formula. Okay, then the oxygen within the molecule will always be -2. The only exception is you have peroxide. Okay. For example, H2O2, hydrogen peroxide. In that case, the oxygen carries -1. Oxidation number. But in all other molecules that contains oxygen, oxygen will always carry -2. Okay. For your H, you will typically always carry +1. The only exception is actually when they work with the 1A element. Okay. Then they form these things called a hydride. Then under that specific case, the hydrogen carries -. Okay. For your 1A element, it's always +1. 2A element is always +2. 6A always -2. 7A is always -1. Okay. So everyone have an idea about when I talk about 6A and 7A? 7A is the halide, they call it, okay? Fluoride, bromide, iodide, that's 7H. It always carries -1, okay? 6A is what? Oxygen, sulfur, lead column, carries -2. Okay, so if you have a periodic table on hand, right? It's basically the things on the very left is +1. Second left, +2. Okay, and I start from the halide, -1, and the row and the column right next to it is -2. Okay, it's symmetric. If I have a periodic table in front of you, okay, mark it down. Okay, so you know when you go to class, you see a periodic table, you know which column is +1, which is +2, -1 and -2. Okay, so those are the very simple rules that we actually know. Okay. And then the very last rule I want to know is that if you have molecules which are composed of many atoms, right? If you add up all the oxidation number of all atoms, then the final number must agree with the overall charge of the molecule. Okay, for example, H2O, the overall charge is 0, right? So you know the oxidation number of the H and O, when they add up, it has to equal to 0. Okay. But if today you have a molecule is, let's say, NO4 minus, which by itself carries overall -1 charge, right? That means your oxidation number of your NN and the oxidation number of O, when they all add up, it has to be equal to -1. Okay, so that's actually what I mean by the very last rule. Okay. So now I want to actually give you some examples so you can actually see the very last one more clear. Everybody know this molecule, right? Okay, and then O for a very strong oxidant. Okay. So what's the overall charge? 0, right? So you know overall charge is 0. Okay. How many atoms do you have within this formula? 6, right? You have 1 potassium, 1 manganese, 4 oxygen. Okay. So can you see that the potassium carries positive 1 charge? Right, because actually the 1A element. Okay. So you know potassium carries positive 1. Oxygen carries -2, right? And you have 4 of them. Okay. Can you actually see the oxidation number of your manganese, Mn, will equal to +7, right? Because you know +1 plus your oxidation number of your manganese plus -8. That equals to the formal charge 0, right? Therefore, you know the oxidation number for your manganese has to be +7, right? So these are the things that we'll be very, very good at for this chapter. Okay. So in order to actually make yourself read at this, the things that we have to practice a lot is actually to understand the things I say, like H always +1 unless you have hydrogen, right? Oxygen always -2 unless you have two outside. Okay. 1A always +1, 2A always +2. 6A -2, 7A -1. Okay, so those are the things that you have to really memorize. Okay, and use your PR table to know all these elements. Okay, so that's actually the most important things that we have to become a master for this chapter. Okay, so those are the fundamentals. But the things that you can test the most is this. Balance your redox reaction in aqueous solution. Okay, so for the CHEM1312, every time you think about this redox reaction, we are always talking about the redox reaction in aqueous solution. Okay, that means the pH is going to be something that's important. Okay, so in all this redox reaction balancing, it will always tell you you're in an acidic solution or basic solution. Okay, and the reason that is important is because when you balance all these redox reactions, you need to actually use the H or OH minus or H2O to fill in those missing atoms inside your equation, okay, which you'll see those things later, okay. But for some of these redox reactions, okay, I give you actually 4 major steps, okay. So all you do is actually follow those 4 steps, okay. But before you can actually do all these steps, the first thing that you really need to learn is these 2 terms, okay. Low rock and G rock, okay. These 2 terms are my own invention. You will never see these things in any textbook. Okay, but I find it actually very useful. So stay with me. Okay. So I guess by now you guys will see that I'm a person who is actually really good at summarizing things. Okay. I always try to create something that helps me to study. Okay. You should do the same. Okay, all the things I do here, just trying to give you one example. You will not all this knowledge from textbook. Okay? But what kind of things will come to the content of textbook? People know for long time. Right? But knowing that give you any advantage like others. You need to think about this because it's actually important for your life. Okay. All the things that we learn, all the knowledge that you have learned inside the university, those are the knowledge people found very useful. And so just the base of the things we are going to pursue in the future. Okay. So it is nothing. They have actually very specific and standard way to actually tell you how things happen. Okay, but knowing that alone doesn't put you in a position that you will be actually taking any advantage of that. Okay, let's say the basic, right? So what are the things that people are looking for? To actually move our life to a better status, we need what? We need inventions, right? I try to invent how I understand the material. Okay, that's the things I always do. Okay, so I don't know whether I can mention to everybody that my main job at University of Houston is not teaching. Okay, so teaching college occupy 10% of my time. 90% of my time is doing what? Yes, so I'm a research professor. Okay, so meaning that the main thing that the school want me to do is doing research. Okay, so what does doing research means? Doing research means actually explore something that other people never know. Okay, so that's the things I enjoy to do, and those things actually revealed here. Okay, I try to create some interesting way that I can memorize and see the people, see the things that people did not see in the past. So I realized this actually may be a better way to help me to handle a topic like this. Okay, so you guys have different majors, right? The things that really matters is not this specific content. Okay, this actually I call surface information. It's not important. The things that really matter is actually why I do this way. Okay, so see that and do it through yourself. So everyone has different interests, right? And that's fun. It's really interesting. Yeah, but I feel like always there's actually some underlying pattern that everybody can use. Okay, I think that's actually a very important value when you go to university because you can really see someone who's really good, they're actually really smart. Okay, and you just see what they do on the surface, but see what's the intention. Why do they do that? Okay, seeing that way to put you in a different level. Because most of people, is 80 to 90% people will only see the surface information. But in order to actually have really improve your life fundamentally, the things that really matter is actually the underneath information. See the structure, see the principle. Okay, they will actually help you greatly in the future. You can really understand what I'm talking about. All right, so get back to this. Okay. LoRa and GRAP, we're going to use that over and over and over again for the midterm 3. Okay, so what does LoRa and GRAP means? LoRa is actually a combination of several different letters. Okay. It stands for lost electron. The species undergo oxidation. It can serve as a strong reductant. And this thing will always happen if you have electron chemical cells, which we're going to teach later on. This reaction will always happen at an anode, okay, which was always labeled with this negative sign. Okay, so remember this because we're going to use this over and over again. Okay, LoRa means the atom you're looking at is losing electron. It is undergo oxidation. Okay, when I say undergo oxidation, meaning your oxidation number is going to increase. Okay, because later I'm going to practice a lot with equations. Then I will ask you, okay, who is my LoRa? Once you hear that, the things that you need to do is actually start looking for the atoms whose oxidation number is increasing. Okay? And since your oxidation number is increasing, it means actually you give up electrons, right? So you're going to reduce your interacting partners. Therefore, yourself will be a reductant. Okay, so friends, when I say reductants, openly you're going to see the other term called the reducing agent. Okay? Okay. So the rare things, anode, Okay, so at the very end of this chapter, we're going to start to talk about this also the electrochemical cell. Or hopefully you're going to see the term called the galvanic cell or vortex cells. They are all the same. Okay. So then we're going to introduce all the components of the cell. And one of the important components is actually anode. The other one is actually cathode. Okay. For your anode, it will be always the component where your oxidation reaction will occur. Okay, meaning that that's actually always the place you can write out your low rock equation. Okay. G rock, on the other hand, is the reduction reaction. Okay. So oxidation reduction, this thing will always happen simultaneously. Okay. If I undergo oxidation, then it's actually someone else is reduced. Okay, so these two must form a pair. Okay, it's always show up as a pair. Okay, so G-rock means you gain electron instead of lost electron. Now you're going to gain electrons. Yourself are reduced, meaning that your oxidation number is going to decrease. Okay, and then you can actually serve, since you're actually going to strip the electron from others, right? So you serve as a strong oxidant. And this process will always happen in the vessel. Okay, so those are the things that you need to actually memorize. Once you memorize, then we go to the most important part. Lecture. So actually all that to balance your redox reaction. Okay, so first step is of course write out the two half reactions. And then you can actually write out your lower and also your G-rock equation. Okay, so once you've done this lab, and if you look at your half equation, you'll realize look at some atom is missing. Okay, so the atom that's missing typically is either H or O. Okay, so these are the two commonly seen missing elements inside your half reaction. Therefore, you have to balance those atoms first. Okay, so based on the solution that you have, then you use different species to balance it. If you use under an acidic solution, if you're missing an H, then the species you use to balance that is always H plus. Okay, but if you're missing O, then you use H2O. Okay. In contrast, if you're actually in the basic solution, if you're missing H, you use H2O. If you're missing one O, okay, there's one single missing O, then you add in 2 OH minus to balance it. Okay, so the reason you use 2 OH minus is because you want to actually further later on after that step you need to actually further balance your H. Okay, you're going to see the example very soon. Okay, but you need to remember if you're missing one O, then you add in 2 OH minus. Okay, and once the missing O, the O is the oxygen doesn't belong to OH minus. You'll see that example too. Okay, but bear in mind with that. Okay, and then after you balance all the atoms, then you actually balance all the charges with electrons. Okay, and once you balance the atom, balance the charge, then you add up the two happy reactions, then you got a balanced redox reaction. Okay, so those are 4 steps. Step number 1, write out your low rock, write out your G rock. Number 2, balance your atom. Okay, for your oxygen and hydrogen, OH. Okay. Number 3, balance your charge. Number 4, add up the two happy reactions. Those are the rules that we always will need to follow. Okay? So let's do some examples so you can see these things clearly. Okay, it says balance the following redox reaction. In acidic solution, use the lowest possible integer that gives the coefficient of H plus. Okay. And this is actually the equation. Okay, so let's start from the QT pack. Okay. What's the question? You want to find out the coefficient in front of H plus. Right? So that is actually the things we want to solve. Okay. Theta. What kind of solution do we have? Acidic. Okay, so acidic, if you're actually missing your hydrogen, you use H plus. If you're missing your O, you use H2O. Okay? And then the equation that you have is Cl2 plus H2S becoming S plus Cl minus. So that is actually equation that you have. Okay. So now the things you need to do is actually start to assign the oxidation number for every single atom. Okay. What's the oxidation number of Cl? Good. Okay. We need to practice this over and over again, okay? How about H2S? H will be plus 1. You have 2 of them, right? S will be. Okay, very good. How about this S? How about this Cl? Minus 1. Okay, so we finished all this oxidation number assignment, right? So after this, then we can just start to run the full stack. Look at this. Who will be your LoRa? So when I say LoRa, is that we're going to looking for the atoms with both electrons, right? Meaning your oxidation number is going to increase, right? Whose oxidation number increase? Right, that's actually your LoRa, right? Because your oxidation number goes from -2 to 0, right? The oxidation number from -2 go up to 0. So oxidation number increase is undergo a LoRa. Okay? Who is actually your G-rock? Right? That's actually your G-rock, right? Is this clear? Okay, so let's write out your LoRa. LoRa will be H2S becoming your S, and your G-rock will be Cl2 becoming Cl minus. Okay, so that's actually your first step. Okay. Second step, we need to balance the atoms, right? So if you look at the things that undergo your LoRa, you have one sulfur. Okay, so sulfur is actually fine. Okay. Then you look at the H2S, right? Compared to your product side, you have 2 extra H, right? So you're going to balance that in acidic solution. Therefore, you're adding what? You're adding 2H plus on the other side. Okay, so you balance the atom for your LoRa. Okay. Then we look at our G-rock. You have 2 Cl on the left, you have 1 on the right. Therefore, simply multiply a factor of 2 on the right to balance the atom. Okay? Any question for this step? We're good? Okay, so finish the second step. Third step, balance the charge of your low rock and G rock. Okay, so how do you do that? If you look at this, on the left, what's the charge? 0, right? On the right, you have 0, 2 plus, right? So it's 0 on the left, but positive 2 on the right. So that's your balance that using your electrons. Therefore, you will need to add in 2 electrons on the right, so that both sides have the same amount overall charge, which is 0 in this case. Any question for this step? I don't get your question, sorry. Yes. Right. So electron carries positive 1 or negative 1. The electron carries negative 1 charge, right? So 2 of them becomes negative 2, right? And then you have 2 H plus, which carry 2 plus. So adding up, it becomes 0. Okay, make sense? Okay. All right, how about the G rock? You have 0 on the left, 2 minus on the right, right? So where are you going to add electrons? On the reactant side, right? How many electrons do you add? 2 electrons, right? Okay, then you balance your G rock as well. Okay? So now we finish step number 3. We move to step number 4. Okay, so step number 4 is actually time to add up your G rock and then low rock. But before you add up, one thing you have to be careful is like the electron that was produced by your low rock must be the same electron that was accepted by your G rock. Okay, for your low rock, how many electrons do you generate? You give out 2 electrons, right? For your G rock, how many electrons are you going to take? 2. So under this case, everything's at the balance. Okay, so then what the things you have to do is actually just adding up. So once you're adding up, you have H2S plus Cl2 plus this electron and the electron will cancel out, right? So this becoming S plus 2H plus 2Cl minus. Okay, so this will be your balanced. This will be your balanced redox reaction. Okay. Now we go back to the question here. What are the things that we're actually looking for? It's the coefficient in front of your H plus. In this case, you will know the answer will be 2. Okay. So this is actually how you solve how you actually balance the redox reaction, following the 4 steps. Any questions, please? I'm missing the CO2.
CO2 on the
Oh, sorry. Okay. Any other questions? We good? Okay, let's put it. We have 3 more to go for today. Question number 2. Balancing the following equations in, I'm going to highlight a few keywords for you, okay? Basic solution. And try to find out the lowest possible integer that give the coefficient in front of your hydroxide atoms, right? So Q, coefficient or OH minus, right? Theta, you have basic solution. Therefore, if you're missing hydrogen, you use H2O. Missing oxygen, you use 2OH minus. Okay, so those are the setup that you have. Then we write out the equation. MnO4 minus plus C2O4, 2 minus, they give you MnO2 plus CO3, 2 minus. Okay, so this is actually the equation that we have. Okay, then we start to actually assign the oxidation numbers, right? For your oxygen, this will be -2 times 4, right? So your manganese will be +7. Okay, everybody can see this? Make sure you can do this, okay? Second, you have oxygen -2 times 4 overall -2, meaning that your C2 will be +6. Therefore, you know C will be +3. Okay. The same here, -2 times 2. Therefore, your manganese will be +4. This will be -2 times 3, that's -6. I have -2 here, meaning this is actually also +4. Okay. Everybody fine with the oxidation number assignment? Any specified actually related? Very good. Okay. Now, the fourth step. Who is your lower? Who is your lower? Whose oxidation number increase? Okay. I hope you see this. Right? So let's go lower. This. There will be a G-rod, right? Then you just write out those equations. C2O4, 2 minus, becoming CO3, 2 minus. The other one will be MnO4 minus, becoming MnO2. So that's the first step. Okay. Second step, balance atom. Okay, so let's look at this. So we know the things that undergo the lower is this carbon, right? So first, balance the atom. You have 2 on the left. Therefore, put 2 to make it balanced first. Okay. After that, then you start to look at this. On the left, you have 4 oxygen. On the right, you have 6 oxygen. Okay. So which side have more oxygen? Is actually your overall. Okay, which side has more oxygen? The product side, right? On the product side, it's 6 oxygen atoms. For the reaction side, only 4, right? Therefore, you don't actually fill in those missing oxygen, right? So we are in the basic solution. If you miss 1 oxygen, you add 2 equivalent of OH minus. Okay? Therefore, you need to put in 4 OH minus to balance your oxygen. Okay? So once you do that, the oxygen will be balanced. All right? It's not right. Why? Because there's actually some other things you will also need to balance, which will be your hydrogen. Right? Because any OH minus, right, you actually introduce the H on the left-hand side. Therefore, you actually further balance that. So how do you balance the hydrogen? You add in H2O. But when you add H2O on the right-hand side, you also bring more oxygen, right? So that's why later you'll see why it has to be 2 equivalent, because you need to compensate the subsequent adding H2O. Okay, so let me show you this. So on the left, right now I have 4 more hydrogen. Therefore, you add in 2 H2O. Right, you have 4 extra H, right? We're going to add in 2 equivalent H2O, give you 4 hydrogen. Okay, but once you do that, you realize everything is actually balanced afterwards. Okay, so the reason that in the basic solution, when you're missing an oxygen, you add in 2 equivalent of OH minus is because there's actually a subsequent step. Then you actually further balance your hydrogen. Okay, so the result actually, you actually add in 2 equivalent of OH minus in this case, since we're missing 2 oxygen. Therefore, we add in 4 OH minus. And if I actually add in back the H2O, then everything will be actually balanced. Okay. If you don't understand what I'm talking about, just pretend that you trust me and following the same step, then you'll get the correct answer. Okay. So if you look at this, let's check it. How many oxygens on the left? 4, 8 on the left, right? 2, 6, also 8. So both have 8 oxygen. Okay, on left and right. How about hydrogen? We have 4 hydrogen on the left. Yeah. 4 hydrogen on the left. 4 hydrogens on the right. Then everything will be balanced. Everyone follow so far? Okay, so this is actually something that you will need to actually know how to do. Okay? Okay, next one. Starting from the atoms that have undergo the G-rock, right? So you have 1 manganese on the left, 1 manganese on the right, so everything's fine. The remaining difference is what? You have 2 extra O on the left. They're going to add in how many OH minus? If you're missing 1 oxygen in the basic solution, you need to add in 2 OH minus. How many do you miss here? You miss 2, right? You're going to add in how many OH minus? 4. Okay, so. Okay, once you add in 4 OH minus, then you need to actually balance the hydrogen, right? Therefore, you add in 2 H2O, then everything will be balanced. Okay, so in the basic solution, this is actually something that students always get lost. But it's very important to see this If you know how to actually do this, you solving this problem becomes a lot easier here. Okay, any questions for this step though? Good. Okay, so after balance the atom, the next step will be balance the charge. Okay, so this carries -2. This carries negative. What's the charge of this? -4. Okay, this will be 0. This will be -4. Okay, so on the reactant side, you have overall -6. Other side, -4. Therefore, you now need to add in how many electrons? 2 electrons. Okay. How about your G-rock? This will be -1, 0, -4, 0. Okay, so how many electrons you need to receive? 3 electrons, right? Therefore, you know you need to add in 3 electrons. Then the charge will be balanced. That's your step number 3. Any questions so far? I want to make sure everybody understands this too, because yeah, the coming two will be actually even more challenging. Okay. So now, this is actually all the atoms are balanced, charge are balanced, right? So we are ready to add it up. But before we add it up, we want to actually make sure the electrons generated from your G-rock, from your LoRa, to equal to electron they can receive by your G-rock, right? But are they the same? They are not the same, right? Because you can see this is +2. Let's add in 2 electrons, right? And this is receiving 3 electrons. They are not the same. So we can make it the same before we add it up. Okay, so the way to make it the same is that you multiply 3 for your roller and add up 2 of your G-rock. Right? So let the electron, yeah, will cancel out in the end, right? So once you do that, okay, let's rewrite that. You will be 3 C2O4 2 minus plus 12 OH minus becoming 6 H2O 6 CO3 2 minus plus 6 electron, right? So let's actually use 3 times of your LoRa. 2 times of G-rock will be 2 times 3, 6 electrons plus 2 MnO4 minus plus 4 H2O. They give you 8 OH minus plus 2 MnO2. Okay, so this will be the 3 times of LoRa and 3 times of G-rock. Okay, so once we finish that, then we can see that the electron produced by your LoRa is equal to electron that's receiving from your G-rock. Okay, then we can actually adding up. So we can start to cancel all things. This will cancel out with this, so it's 4 remains. This will cancel out that, that's 2 remains. And this will cancel out with that. So you have 3 C2O4 2 minus plus 4 OH minus plus 2 MnO4 minus. They give you 2 H2O plus 6 CO3 2 minus plus 2 MnO2. So this will be your final balance, the redox reaction. And it is asking for the coefficient in front of your OH minus. Therefore, the answer will be 4. Okay. So this is actually how you solve these questions. Okay, so compared to the one we just went through the previous question, this one getting a little more confusing because we are talking about is in the basic solution, right? So we are missing oxygens in two equivalent of OH minus. And then you aim H2O to further balance your H afterwards. Okay, but this is actually something you have to get used to it. Okay, any question for this? We good? Next. Balance the following equation in acidic solution. And want to find out the coefficient of H2O, right? So Q is your coefficient of H2O. Theta, you have acidic solution. Therefore, mixing hydrogen using H plus, mixing oxygen using H2O. Equation Cu plus HNO3 give you CuNO3 2 plus NO2 plus H2O. Okay, so that's getting more and more complicated now, okay? So again, assign the oxidation number for your atoms. Oxidation number of your copper. Good. Multi-atom molecule, right? Starting from the oxygen. -2, you have 3 of them, right? Hydrogen, +1, right? Therefore, your nitrogen will be +5, okay? How about this? CuNO3, 2. What's the oxidation number of a Cu? Right, so here actually become not so straightforward. Right, so a few things that I want to mention here, so that in the future when you see these things, you don't feel terrified. Okay, let's look at this. Okay, for this multi-atom elements, okay, so remember, I asked you to remember the chart of some of the multi-atom anionic species. For example, HNO3, right? I asked you to remember NO3 -1, right? So let me write those things out. Okay, so this actually is called a multi-atom anion. It carry actually a very specific charges, right? So CM carries -1, NO3 carries -1, SO4 carries -2, PO4 -3. Okay, so memorize these things will actually help you greatly. Okay, this species, if that is actually form that have the oxidation number doesn't really change, they're actually very stable. Okay, so there won't be the LoRa or G-Rock you're looking for. Okay. So with this in mind, okay, can you see that this is actually positive 2? Because your NO3, this one, carries -1. You have 2 of them, right? So that part is -2, but overall it's actually neutral, which makes your copper become positive 2. Okay, so that's how you actually solve this oxidation number assignment here. Any question for this? Oh, everybody actually can accept the things I just said. Okay, there are a few multi-atom anions that you actually memorize. You need to know the charge. Okay, which will make many of these questions a lot easier to handle. Okay. Then we look at NO2. O, -2, you have 2 of them. Therefore, you know your N will be +4. Okay, H2O, oxygen will be -2, hydrogen will be +1. Okay, so let's actually how to assign the oxidation number for this specific equation. Any questions for this? Okay, if not, then tell me who is my LoRa? Whose oxidation number increase? Copper, right? You see this? Go from 0 to +2. That's your LoRa, right? Who is my G-Rock? Nitrogen, right? Which nitrogen? You see this? And to be actually very accurate to know which one. Okay. So LoRa will be your copper becoming copper NO32. G-Rock will be HNO3 becoming NO2. Okay, that's all into right first. Okay, so once you identify your LoRa, once you identify your G-Rock, next one will be balance the missing atoms, right? So if you look at this, starting from the one that undergo LoRa, right? One compound on the left, one compound on the right. So copper is actually done. Okay, but if you look at this, you have these things, right? You have 2 extra NO3 minus. Okay, so what are the species we can use to balance that? What will be the things you use to balance the extra NO3? Yes, the only species you can use is HNO3, right? Therefore, you know, into in 2 equivalent of HNO3. That's the only thing that you have. Okay. So once you do that, you balance your NO3. But at the same time, you introduce what? 2 extra H. Right? So you can further balance the H, therefore you add in 2H plus on the right to balance your H. That's right, athletic solution. Okay, then up to this point, then you balance your LoRa. Any questions? Is this clear? Okay. Once we're done with that, the next is what? You work with the bottom one, right? You work with your G-Rock. Okay. You have 1 nitrogen here, 1 nitrogen here. So nitrogen is actually done. Okay. Then what? So which one should you do? Okay. So which one should you do first? Should you do oxygen or should you do hydrogen? Do the oxygen first. Very good. That's actually reasonable. Because once you actually do your oxygen, okay, once you balance your oxygen, the very next thing you need to balance is your hydrogen, right? In acidic solution, all you need to do is actually just add in H plus. It's not going to introduce further complication. Okay, therefore you do your oxygen first. Okay, so if you look at the oxygen, you have one extra oxygen on the left, right? Therefore, you want to add in one H2O first. Therefore, you balance your oxygen. Okay. Next time come your hydrogen. You have one on the left, you have two on the right. Therefore, you only need to add in a H plus, then you're done. Right? Then you are done with the balance for your atom for your G-rock. Okay. Then the next step will be let's balance the charge. Okay, so this is 0, 0, 0, positive 2. Therefore, how many electrons should you add? 2 electrons. Okay. How about your G-rock? 0, positive 1, 0, 0. So you add in 1 electron. Okay. So charge will be balanced for both. Then you can move to the next step. Okay, since you actually have 2 for your LoRa, 1 for your G-rock. Therefore, you know you need to do LoRa plus 2 G-rock. Okay. So if you do that, so if you do 2 times your G-rock, you're going to have 2 electrons, 2 HNO3, 2 H plus, 2 NO2, 2 H2O. Okay, so we're going to add LoRa and then your 2 G-rock. Okay, so when you do that, this and that will cancel out. H plus will cancel out. So you're going to end up with copper plus 4 H NO3. They're becoming copper NO3 2 plus 2 NO2 plus 2 H2O. So this will be your balanced redox reaction. The coefficient in front of your H2 will be 2. Okay, so let's check how you solve this question. Okay, so the things that is make this things a little bit more complicated is that we start to introduce the concept of multi-atom anion. Okay, so there's a few ones that you have to memorize. The one I list here will be Cn minus 1, NO3 minus 1, SO4 minus 2, PO4 minus 3. Okay, so those are the 4 species I think you are going to actually memorize this charge. Okay, so that's how we solve question number 3. I hope we have time for the very last one. Okay, so questions. Balance the following equation in basic solution. And you want to find out the coefficient in front of your OH minus, right? So Q, coefficient of OH minus, theta, basic solution. Missing hydrogen, use H2O, missing oxygen, using 2OH minus. Okay? So equation Ag plus Cm minus plus O2 becoming AgCN2 minus plus OH minus. So that's actually the equation that we have. Okay, so let's assign oxidation number. What's oxidation number of your Ag? Okay, I hope by now you should know this. Okay. Cm minus. Okay. This is actually one of the multi-atom I mentioned, right? So when Cg is just leave it there for now. Okay, don't do anything. Okay. Oxidation number of O2 for your O. 0, right? How about this? So you have 2 Cm minus, right? Let's make it 2. But OO carries 1. Therefore, your Ag will become positive 1. Okay? How about this? Negative 2, positive 1. Right? That's all. Okay? So after this, then you can start looking for your LoRa and GROC, right? Who will be your LoRa? Silver, right? Because it goes from 0 to positive 1, right? So that's your LoRa. GROC will be who will be your GROC? Whose oxidation number decrease? Yes, oxygen. Okay, so this and that. Okay, so LoRa will be Ag becoming AgCN2 minus and your GROC will be O2 becoming OH minus. Okay, so that's actually the first step. Second step, we need to actually balance our atoms, right? So if you look at your LoRa, you have one Ag on the left, one Ag on the right, so your Ag is fine. The only thing missing is what? You have 2 extra Cm minus on the right, right? Therefore, you add in 2 Cm minus. Okay, then you balance your. Okay. Now this part becomes very interesting. GROC. Okay. So it's O2 become OH minus. Okay. So remember when I say when you counting, okay, the extra oxygen, okay, in the very beginning I talk about a principle, okay, is the extra oxygens besides those oxygen in H2O or hydroxide. Okay, that is actually specific for this case. Okay, so If I do not really say that, what would you do? You actually count the difference in terms of oxygen and the right. So on the left, your reference side has one more oxygen. Therefore, on the right side, you have to add in 2 OH minus, right? And you realize we will never be able to balance it. Okay, because oxygen, H2O, OH minus, okay, especially OH minus and H2O, they are both inside the water that exchangeable. Okay, so when you do the balance, it's very, very confusing. Okay, so what I will tell you to do is that specific comp, okay, ignore all the oxygen from the OH. Pretend that's not there. Or in the beginning, okay. It means actually you start on with 2 oxygen. Okay. That means on the right hand side you have how many OH minus? You have 2 oxygen on the left. You have 4 OH minus on the right. Okay. So right now how many do you have? 1, right? So all you need to do is actually say, okay, I need to put 4. Okay. So once you do that, then you can further balance your H with 2H2O, and that's it. Okay. So every time we say extra oxygens, okay, ignore the contribution from hydroxides. Okay, so if you have hydroxide on the other side, right? Pretend it doesn't exist first. Okay, then count, okay, how many oxygen that you have. In this case, you have 2 oxygen, right? Therefore, you know on the right hand side, you must have 4 hydroxide. Okay, then you go back to there, okay, I have 4 again. Then let's put the coefficient 4 in form of that OH minus. Okay, so this actually things you are going to see for more complex questions, okay, which they're going to show up is OH minus on the other side. Okay, so in order to actually make the framework still work properly, okay, you need to first ignore that oxygen in the OH minus. Okay, so let's start from the O2 on the left, then you know you have 4 on the right. Okay, then things will actually become easy again. Okay, so up to this point, you balance all the atoms already. Right? The next step will be balance the charge. Okay, so if you look at your LoRa, 0, -2, -1. Therefore, you know to add in 1 electron. Gira, -4. Therefore, you add in 4 electrons. Okay, I'm almost done. Give me a minute. Okay, so once you have this, then all you need to do is actually do your LoRa plus, okay, 4 times of LoRa plus your Gira. So that the electron will agree with each other, right? So 4 times of LoRa will be 4 Ag plus 8 Cm minus. That gave you 4 Ag Cn2 minus plus 4 electron. Your Gira is actually 4 electron plus O2 plus 2 H2O. That give you 4 OH minus. Okay. Adding up this and that will cancels out. That's it, right? So answer, the final balance one will be 4 Ag plus 8 Cm minus plus 2 H2O plus O2. That give you 4 Ag Cm minus Cn2 minus plus 4 OH minus, right? So this will be your balanced redox reaction, and the coefficient in front of your hydroxide will be 4. Okay, so this is actually how you solve these questions. Okay, I hope you can go home and practice this one. Make sure you know how to calculate all the population number. Sorry, I'm a bit late, but that's it for today. Thank you.